As agents take on more responsibility, reliability becomes critical, not just after the fact, but while the agent is working. Joining us as a principal researcher from our MSR India Research Lab, Amit Sharma is here to announce Interwhen. This is a new open source approach to test time verification that lets agents check each step of their own behavior using verifiable properties extracted from natural language. This work sits right at the intersection of theory and practice, and it tackles one of the hardest problems in agentic AI today, knowing when a system is behaving correctly. Over to you, Amit.
Hi, I'm Amit Sharma, a principal researcher at Microsoft Research in India. And today I'm excited to introduce Interwhen, a framework we've built for steering reasoning agents with real-time verification. This is joint work with my colleagues at MSR India, as well as Professor Subbarao Kambampati from Arizona State University. AI systems today are moving from passive generators of text to agentic systems that can execute actions in the real world, either through tool calls or other means. For example, consider an agent that is operating your inbox or executing complex workflows in an organization, or even interacting in the physical world. These agents are equipped with tool calls that can do irreversible changes. For example, it can send an email on your behalf, write to an organizational database, or even move an actual robot next to you. So it is critical not just to verify their final output, but also the intermediate actions. So a central question for us is, how do we go from agentic execution, that's today, to a future with verified agentic execution? Let's look at the current verification systems and their limitations. Typically, the verifier would have access to the model response at time t, the task instruction, and even some domain policies. The first approach uses LLM as a judge, but this is a monolithic verifier, and the LLM might miss nuanced errors, and so this is unreliable. In the second approach, we can use formal verifiers. Now, these are reliable, but they're restricted to math and code. To address these challenges, we have built Interwhen, a real-time framework for agent verification. We'd want to use formal verifiers for general domains, but how do we apply them to this kind of a setting where there might be thousands of tokens and almost everything is ambiguous? The key innovation we have is an LLM-based projection step that automatically breaks down outputs into a list of verifiable properties, the desirable properties you can think of that any solution should satisfy. And now the framework can automatically generate formal spec and create a provable verifier in Python or Lean. Note that the system is not just operating post hoc once the agent is done. It can actually verify a partial model response at any point of time, give actionable feedback, and steer the reasoning model to avoid any violations. We have two important design principles here. First, verification runs asynchronously so that the entire system is efficient. And second, it's plug and play so that practitioners can bring in their existing verifiers as well. Now, let me go tell you how it works in a real-world setting. We are finding that Interwhen leads to state-of-the-art results on agentic benchmarks such as Tau2 bench, where even small models can rival the accuracy of frontier models. Let's see how this works. First step is to extract verifiable properties. These are structured atomic properties that any solution should satisfy. For example, in Tau2 bench, we have a scenario with a retail agent, and you'll have a policy which is a lot of text, but then it gets converted to verifiable properties, such as a refund must go to the original payment method. And with this property, we can now actually automatically generate Python code that acts as a verifier for it. And this is a one-time operation that can actually be assessed and checked. And then the magic happens at runtime when the variables of the Python verifier are dynamically filled in based on the user's context and the model's current response. For example, here, the agent tries to return some items based on the user's request, but it uses the wrong payment ID. The verifier fires in, it checks that a violation has been made, and gives a message, refund to credit card not allowed. We see that in the next turn, the model takes this feedback and corrects its mistake. A key design decision that we have made is efficiency. Verification should not only ensure correct output, but it should also be practical for people to use it. Hence, we have built a separate monitor system that tracks the agent's output in real time and calls verifiers asynchronously for all reversible tool calls. The property here is that the agent's execution is stopped only if an error is found, otherwise, it goes as designed. Finally, the framework is general enough, and we have found it leads to significant increases in output quality across tasks, including customer service, as I mentioned, travel booking, logical puzzles, and even ensuring safety of agents' responses. The key benefit that it is plug and play. It works for both proprietary and open weight models and ensures 100% verifier enforcement. That means the agent provides no answer if the verifiers do not pass. I'm excited to announce that we have open sourced Interwhen on GitHub. At Microsoft Research, we believe in open collaboration, and our goal here is to foster a community focused on AI verification and safety, where we can collectively build and test verifiers on real-world use cases and enable a future where all agentic execution is verified. If you'd like to learn more about Interwhen, you can visit the link below. Thank you.